Let me spend a little time on weather data. So by default, SAM has a list of TMY2 files. So these are weather files that were prepared by NREL for a few hundred locations in the United States. That database has since been updated to the TMY3 database. When you click these links on the climate page at the bottom there, they actually will open the relevant websites on your web browser. So this is the website for the TMY3 database in the U.S. And you can download files for 1,000 or so different locations in the U.S. So SAM can read these files. If you're, and I'll walk through the steps of doing that in a moment. If you're modeling a system outside of the U.S., there's a database of weather files that SAM can read on the Energy Plus website. And these are files in the EPW format. And you can download those files here. So you download one of these EPW files by right-clicking and saving, and save it to a weather folder, and then that file will be available for use in SAM. I'll walk through the download process in more detail in a moment. You also have the option for U.S. locations of typing in an address. And this is using the Google API, so you can use the way you type addresses in Google. Type in these addresses. And this will go to a server, an NREL server, and download a TMY2 file from an NREL database of weather data for the U.S. So you've got TMY2, TMY3, EPW, and then this location lookup, which is data from what's called the Solar Prospector website. So let me just spend a minute describing the difference between the different formats. The TMY2 are typical year data sets that were developed over a period from so the TMY3 data is from 91 to 2005, and the TMY2 data is an older data set that spans a longer number of years, 61 to 90. And the Solar Prospector data is satellite-derived data from 2001 to 2005. So the longer the period that a typical year data set represents, the more accurate you can consider it to be. But the more recent the data set, the more accurate it would be for current data analyses. So there's kind of a trade-off here between the TMY3 and TMY2 data set. The TMY2 spans a longer period, but is an older data set. TMY3 is a shorter period, but is a more recent data set. TMY2 has fewer locations than TMY3. So we basically recommend using TMY3 if you're modeling a project that's near or at a TMY3 site. If you're looking to have both a TMY2 and a TMY3 data set near your site, you might want to run the model using both. And And then if you're at a location that's near neither, you might want to use the solar prospector data. The TMY2 and TMY3 data are based on a combination of ground measurements and computer model data. And the solar prospector data is based on satellite-derived data. So it's data from satellite, taken from satellite measurements. So it's the benefit of the satellite data is that it covers the entire U.S., the entire continental U.S. At a resolution of 10 square kilometers. So you can get data for any location in the U.S., but it's likely to be less accurate than the TMY3 or TMY2 data that are based on ground measurements. There's an excellent new handbook that NREL just published called the Best Practices Handbook for Solar Resource Assessment for CSP projects. If you Google Best Practices CSP NREL, you'll find a link to the document. And it describes the different data sets and has a discussion of relative accuracy and makes recommendations for modelers. And although it's based on, it's written for CSP modelers, it's, I think, also useful for PV modelers. So if you're interested in learning more about your different options for weather data, I would highly recommend looking at that document. Otherwise, I think you can, if you're modeling a system in the U.S., I would say look for your location in the TMY3 data set. If it's not there, then try location. Then use location lookup to use the satellite data. So to download and use a weather file in SAM, you need to do a couple of things. The first thing you have to do is tell SAM where to find the file once you download it, and you do that using the Add Remove button. And you can see here that I've got 2 folders specified as places to look for weather data. One is in my SAM projects folder, in a folder called Weather Data, and one is one that I think SAM created that you can see there. So if I wanted to add another folder, I would just click Add and navigate my computer to find the folder. So I have a folder that I dedicate to all of my weather data. It's called the SAM Projects Weather Data. So if I wanted to download a TMY3 file for Portland, Oregon, I click the TMY3 link on the climate page in SAM. That takes me to the website, and I'll click O for Oregon, and that's Ohio. So I'll go down to Oregon, and there's a couple of different locations for Portland, so I'll just pick one, and I'm going to right-click it, save link as, and now this is important. I'm saving it in the folder that I told SAM is my weather folder, so SAM Projects Weather Data. And I'm going to give it a name that's a little bit more useful than all those numbers, so OR Portland Troutdale. And I'm leaving the TMY ID number in case I need it later. I'll leave that in the file name just for reference. And then I go back to SAM. I need to refresh the list because SAM has loaded the weather files when I opened it, but that didn't include the file that I just added. So I click Refresh List, and then now I should be able to scroll to the bottom of my file or list here, weather data, there, Oregon, Portland Troutdale, and there there's my TMY3 file for Portland. So the steps are: make sure you've got your folder listed, a search folder listed, and then download the file from your browser and click Refresh List, and then got your weather data. The copy to project, this is if you're going to if you're sharing your file with a colleague and you don't want to make them download the file from the website, you can copy it into your SAM project file. And that way, when you email them the SAM file, the My3 file will be in there. That increases the size of your SAM file, so keep that in mind. So for EPW, the process would be similar. You just need to make sure that you're getting an EPW file. And for this particular city, Algiers, there's no EPW link, but this zip file contains an EPW file. So I'd need to download the zip file, extract it, and then put the EPW file in my weather file folder. Now, for those of you who are really ambitious and want to build your own weather files, we have the Create TMY3 button on the climate page. And what this allows you to do is to cut and paste columns of 8760 rows of weather data for each of the data columns that SAM requires. So you need to be sure to have a value for each of these columns. And this is a kind of an advanced feature. I'm not going to walk through the steps here, but the basic outline of the steps are that you need to have a dummy TMY3 file to start with that we call a base TMY3 file. So you open your base TMY3 file, and that populates all these cells with values. And then you need to open your data in Excel, probably, and then you can cut columns of data from Excel and paste it in here. And then when you're done with that, then you click Save as New TMY3 File, and that creates a TMY3 formatted file with your data in it. Now the different models use different columns of data, and there's a table in Help that goes partway toward describing which data goes with which technology, and we actually didn't fully catalog this until recently, and so I think there's a topic in SAM user group which isn't working right now, so I'm not going to waste time with it. But if you want to know which data goes, which columns of data the different technology models use, please check the SAM user group. And if you don't find it there, please email me at the SAM support email address. Okay, we just have about 15 minutes left. And I think I would like to spend a couple of minutes looking at the well, I need to mention a couple of things about the PV model, and then I want to show something about the Trough model, and then quickly show the other technologies. So just a last thing on the PV model. When you, on the module page, I've showed you the Sandia option for PV, where you choose a module from the list of this list of modules. And this list, with each version of SAM, gets updated, and Sandia National Laboratories maintains this database. And the parameters that are behind the scenes here, when you load a module, you're loading a set of parameters, and those parameters were developed by a test, by putting the module out in the weather and taking measurements from it for some period of time. So the only modules that are available in this database are modules that were tested by Sandia National Laboratories and its partners. There's another model called the CEC performance model. It uses a different algorithm. It uses a model called the 5-parameter model that was developed at University of Wisconsin. And it uses a database of parameters that's managed by the California Energy Commission. So the CEC model has a much longer list of modules and more up-to-date list of modules. But the CEC model may not be as effective at modeling thin films as the Sandia model. That's something that we're looking into now. Sandia has a team working on looking at different PV models. So until we have a definitive answer on how well the CEC models thin films, our recommendation is to use the Sandia model, particularly for thin films. And if your module isn't in the Sandia model, then use it. Try using the CEC model. The Sandia model uses an algorithm developed at Sandia National Labs, and you can read documentation of the Sandia model by following the link under references on the Sandia module page. And similarly, there's a description of the 5-parameter model that the CEC model uses on the CEC module page. We also have something called the simple efficiency model. So this is this model allows you to specify the efficiency of the module as an input. So the CEC and the Sandia models, you don't get to specify the module efficiency. The model determines that based on the parameters in the database. With the simple efficiency model, you can specify an efficiency, and the model has the flexibility to assign different efficiency rates for different radiation levels. So you specify. In this case, it's just a 13.5% efficient module whose efficiency doesn't vary with radiation. With the nominal efficiency at 1,000 watts per square meter. But you could use this table to specify a range of efficiency values. And the simple efficiency model does temperature correction, so you need to provide the model with some temperature correction coefficient and some information about how the module is mounted so that SAM knows how to handle what effect the wind and ambient temperature have on cell temperature. You can read about this in help to learn more, and as always, post questions on the discussion board and send email to user support. For the inverter model, you only have 2 options to choose from. There's the Sandia model that allows you to choose inverters from a list of from a database of inverters, and a simple model that allows you to specify the efficiency. So if you don't have a particular inverter in mind, or you want to do parametric studies on inverter efficiency, you can use a single point efficiency inverter and specify the inverter's efficiency. Let me just jump over to the Trough model now, and sorry to be rushing here, but we're running out of time. So on the Trough model, you specify the collectors and receivers and power cycle characteristics. So these are the components of the trough field. And then on the solar field page is where you kind of specify how the components are laid out in the field. And I was hoping to walk through this, but I really don't think we're going to have time. But I can show you an example from the sample file where it's already been set up. So one of when you're modeling a trough system, the first step that you have to take is to determine what the relative size of the solar field and power block should be. And that's going to vary depending on a number of factors. including the location, so the solar resource available at the location, relative cost of different components. So you want to use an optimization process to create a graph that looks something like this. So what this so on the Trough model, you use a value called a solar multiple, which is a way of expressing the solar field area as a function of the power block's capacity. And the optimization problem is to find the solar multiple that results in the optimal levelized cost of energy. Because as you increase the solar field size, you increase the thermal output of the solar field, which gets you more energy, which is good, but you're also increasing the cost of the system because the larger field requires this higher cost. So there's a trade-off between the cost of the solar field and the increase in output from a larger solar field. So by running an optimization on using the levelized cost of energy as your objective function, you can find the solar multiple that balances the trade-off between size and cost. And then, so each of these curves is for over a range of solar multiples, in this case from 1 to 3.25. So we can see how the LCOE varies with solar multiple. And then we're looking at storage as well. So we have a separate curve for different storage capacities. So you can see this curve kind of helps you decide whether to consider storage or not. And then for each size of storage capacity, which solar multiple is the optimal one. I can go through this example in a little bit more detail tomorrow when we talk about parametric analyses. So if there's anyone who's interested in that, I'll start with that in the as the first session. So if you want to join that portion of the webinar, if you weren't planning to join the whole session, I can spend a little bit more time talking about parabolic trough modeling and this optimization process. And then very quickly, I want to show you the different technologies that SAM can model. So we've focused entirely on PV and troughs now. I did mention the other CSP technologies. But in the most recent version of SAM, we've added a couple of non-solar technologies. And again, depending on funding and priorities at DOE and NREL, we may see more non-solar technologies being added to the mix of SAM's modeling capabilities. At this stage, the wind model is fairly limited. We're kind of interested in getting feedback from folks on how they would like to use the wind model and how the one that's in there, how effective it is. So it's sort of kind of at a trial phase now, I would say. The geothermal power model, this is not geo-exchange. This is for large-scale power systems that use either steam or heat from geological processes underground to drive a steam power plant. And there's a solar hot water model for solar water heating applications. And then the generic fossil system model is for modeling fossil fuel-based systems that kind of for baseline modeling if you want to compare renewables to the fossil-based systems. And the fossil model is a very simple heat rate based model, so it's not as sophisticated as renewable energy models. So I think that's what we're going to have time for now. Again, if you're interested in tomorrow's session, we'll be covering advanced simulation techniques, so the options that you see here, parametrics, optimization, statistical modeling. I can also use the beginning of the session tomorrow to tie up any loose ends that may come from questions that are pending. So I guess if there's any questions online waiting, I can take a quick one or two.
At this time, we have no questions in the queue. Press star 1 if you would like to queue up.
I've mostly addressed these remaining questions. So any questions that are...
we have one, sir.
Okay, go ahead.
Give me just a moment. Joanna, your line is open.
Hi. I wanted to see if you choose the utility IPP option, where can you change the bid price? I remember you went to energy, I think the energy technology section, but I didn't see that under utility IPP.
Okay. So if you're using the utility IPP option, which is under utility independent power producer,
okay,
then the power purchase price is an output. You can't.
So it can't be changed.
Right.
Okay.
If you do want to change it, then you need to use the bid price option. So change this from independent power producer to first year bid price. Click OK. And it will say utility bid price here. And then on the financing page is where you specify the price.
So it'll work backwards.
That's right. So then you provide it the bid price, and it calculates the internal rate of return. And again, just be aware that if you use this financing option, you need to make sure that your payment allocation factors are appropriate. So there's no time variation in the price. You want to set all of these to 1. Or just choose the uniform dispatch option here. This payment allocation factors for PV systems are on a separate page rather than on the storage page.
Did you want another online question, sir?
We can take one more.
Thank you. Ben? Jay, can you check your mute button, please?
Okay. I'd like to know if you have a summary of today's discussion in a file that we can download from our website, or if you can email it to us.
Yes, we'll do our best to post a recording on the SAM website and to address the remaining questions that I didn't cover on the SAM Google page.
Thank you.
Okay, so I think with that, we'll call it a day. Thank you all very much for your participation and for your questions. And for those of you who plan to participate in tomorrow's session, I look forward to speaking with you tomorrow.
Thank you, Mr. Gilman. This would conclude today's conference call. Thank you for your participation. You may disconnect your lines at this time.